Hello everyone, I am Pooja. Today we will be exploring the concept of graph abstract data types or ADTs. Graphs are incredibly versatile structures that allow us to model relationships between the objects. In this session, we will dive into how graphs are represented and focus on a specific operation such as deleting a vertex, deleting an edge, checking if a graph is empty, and listing the adjacent vertices. So, what is a graph ATT? A graph is a collection of vertices or nodes which are connected by edges. The graph ADT provides a way to abstract these relationships so we can work with them programmatically. Under deletion, there are two concepts of deletion, that is deleting a vertex and a deleting edge. So let us see what is deletion of a vertex means. To delete a vertex, we have to consider the graph function, that is graph delete vertex of graph comma v, where the graph describes the particular graph in which we are performing the functions and v is the vertex which we are going to delete. So it returns a graph in which v and all the edges incidental to it are removed. So let us understand this by using the beside graph as an example. In this example graph, we have vertices A, B, C and D which are connected with the paths as A, B, A, C, B, C and C, D. Here, if we need to delete a vertex D, then we call the function graph delete vertex of graph, D, where D is the node to be deleted, which is replaced in the place of V vertex. So, before deletion, the graph has completely 4 nodes, and after the deletion, it has only 3 nodes where D is deleted along with its connected links. Now let's get into the second function, that is graph delete edge of graph V1, V2, which are replaced here by B and D as the example. So in this, it returns a graph which is removed by all the edges which have been connected to it. So if you want to remove the edge B, D, then the connection between B and D is removed. We can see by using the before deletion and after deletion graphs. So here after deleting the edge B, D, the connection between B, D is removed and the edges will be reduced by number 1. And the edges are as A, B, A, C, A, D, B, E and C, D, where B, D will be deleted. The next function is Boolean isEmpty of graph. The isEmpty of graph function checks if a graph contains any vertices or edges. The condition to be checked here is a graph is empty if there are no vertices or if all the adjacency lists are empty. So in this example, we have considered a graph G where it has a set of vertices and E is the set of edges. If the output is considered as graph of isEmpty of graph is equals to true, then the vertex and the edges in the graph are 0, and a non-empty graph it will return false if it has at least one edge or one vertex. This function is useful when initializing graphs or checking the termination conditions in algorithms. The next function is list adjacent of graph, V, where V is the vertex which we have to consider to check for its adjacency list. So this function finds all the vertices directly connected to a given vertex V, and it provides the adjacency list which contains the list for vertex V and adjacency matrix which traverses the rows V to find all the vertices where the value is 1. In this graph, we have considered vertices as 6 vertices and it is an undirected graph. So if we want to check the adjacency list for the graph 2, we call the function list adjacent of graph, 2, where this function would return the list 1, 4, indicating that vertices 1 and 4 are adjacent to vertex 2, as we observe in the above figure. So We have covered the basics of graph ADTs and operations like deleting vertices and edges, checking if a graph is empty, and listing adjacent vertices. These functions form the building blocks for the advanced graph algorithms like BFS, DFS, and more. So graphs are powerful tools in computer science, and understanding their operation is a key to leveraging them effectively. Thank you.